All right, so just a quick little intro here on how to type in the inverse on a calculator. Okay? So if I've got a 3 by 3 matrix and I want to find the inverse on the calculator, what I can do is, oops, wrong one. I don't want that one. I want this one. That's what I want. I can go into a calculator page on the calculator, and I can make myself a 3 by 3 matrix. I find it here in the shortcut tab, and this one that looks like a 3 by 3 matrix, highlighted in blue right now. Click on that one, and that's going to allow me to set the size that I need it to be. I want it to be a 3 by 3 matrix, so I'm going to go there. Then I just type it in, 7, 1, 5, 6, 7, negative 5, negative 1, 9, and 5. And then, if I get out of that, if I get out of the matrix and I get over onto the other side, now I can raise that matrix to the power of negative 1. Okay? And when I raise that matrix to a power of negative 1, that is finding the inverse of that matrix. When I hit enter, it takes the value of the determinant and it multiplies it in right away, so you're going to get it in fractional form. Oops, now I lost it. Okay, so then, now let's see what I can do here. Let's move this over here. Oops, there, I just needed to see right there. So this inverse is the 3 by 3 matrix of 2 21st, 1 21st, negative 1 21st, negative 5 over 168, 1 over 21, 13 over 168. Oops, I should have made this a little bit bigger. And 61, 40, negative 8 over 105, and 43. Okay, quick and easy. Type the matrix into the calculator, raise that matrix to the negative 1 power, gets you the inverse. Okay? Now, way we use inverse matrices is we're going to use them to solve complex systems of equations. So here I've got a system of 3 equations with 3 unknowns. I could, eliminate x or y or z on any of those ones, or 2 of those equations, then use substitution or elimination or Kramer's rule or what, some kind of a graphing type thing to solve for that one. Okay? To get x, then y, then z, and so many choices. Okay? Or I could take the same system of equations and I could write it in matrix form, where I take all of the coefficients and I put them in a matrix. So I took all 9 coefficients of my variables and I put them in my coefficient matrix, which is this first 3 by 3 matrix. That then gets multiplied by the variable matrix. In this case, it's x, y, and z. Now, from yesterday, when we were doing matrix multiplication, I would take the first row times the first column. So this row right here times this column right here gives me 10x plus 4y plus 2z, which is right there. And that then equals negative 22. Okay, so that's where that matrix equation comes from. Now, with inverse matrices, I can take the inverse of this matrix, I can multiply that inverse by that matrix on the left side, and I get this now as my matrix equation. and I can multiply those two together, and that will give me then my resultant matrix. Oops, let me see if I can move this over a little bit. There, that's all I need. Okay, so if I take this one, and I need a 3 by 3 matrix, and that matrix is going to be 10, 4, and 2, 2, -3, and -1, -7, -1, and -2. That I need to have the inverse of. And I'm going to multiply that by the 3 by 1 matrix. So now I need to go into here and I need number of rows there, number of columns there. I need it to be 3 by 1 of -22, 17, and 4. And when I do this, now, oops, I gotta move this one back over a little bit some more. I know, riveting internets here going on. And when I do this, now, oops, I get 0, -6, and 1. So that would say then here that x, y, and z is 0, -6, and 1. So x would be 0, y would be -6, and z would be +1 in my equation. So we get -24. If I'm up here, 0 minus 24 is -24, plus 2 is -22. 0 plus 18 is 18, minus 1 is 17, there's 17. 0 minus -6 is +6, minus 2 is 4, and there's 4. So there's the solution to my system.